I'll mess it up. Okay, here we go. Probability. We're doing compound and independent, dependent events today. P means probability. I can't spell it. Probability. The probability or odds. This is also known as odds. What are the odds of winning? Yesterday with the Super Bowl, who were the odds to win?
Ravens.
The Ravens had odds to win. They actually won. So whoever bet for the Ravens won money last night. They're right. Baltimore Ravens, right? Right. It depends on what the spread was and all that stuff, but that's a whole different other thing too. Depends. Right. So probability. Now, when we talk about this more in simple terms, it really comes down to even and odd numbers. Just a review about even and odd numbers on a number cube, an even number on a number cube. What are they? 2, 4, and 6. Okay. On a number cube, an odd number. Okay. Yeah, in general. Probability does not include negative numbers. You can't have negative probability. You have the odds of winning and losing, but you can't like not win. If you don't play, you don't lose because you didn't play. You don't get penalized for not playing, right? Like the lottery, if you don't play, you don't win, right? But do you get penalized if you don't play? No, they don't fine you. Now, prime numbers, here, it's a number with only one factor. A prime number is a number with only one factor. For example, 1 times itself. 1 times 1? 1. Is 2 a prime number?
No.
Yes. 1 times 2, and that's it. How about 3?
Yes.
Well, 5. 4 is not prime. 4 is 1 times 4, 2 times 2. 6 is not prime. 6 is composite. So we know we have 4, we have 6. 7 is prime. 1 times 7.
11.
Is 8 prime? No. 8 times 1, 4 times 2. 9? 9 is composite. Has more than 1. 10? 10 is also composite. It has more than 1. 1 times 10, 2 times 5. But 11 is prime. 12? Composite. 13? 14. And then do you see where I'm going with this? Okay. One factor, many factors. 1 times 1 and all that stuff. Replace versus not replace. Replace versus not replace. Now, when you replace something, let's say you break the window. Are you going to replace it? Well, most people would. Okay, maybe you did. But most people will replace it with glass, right? Same thing here with probability. Now, it's like when you reach into that bag, you pull the marble, you put it back or you don't put it back. So here, replace means to put back. To replace. In probability and math, you reach in the bag, you pull out the marble, you see it, you put it back in. You replace it. To not replace, you don't put it back. You reach in, you take it out, you leave it out. Replace versus not replace. Okay. Let's do our first example. Bless you. A 6-faced die is tossed, a spinner is spun, and a card is pulled from a deck. Alright, let's say this is a 10-face spinner. There are 10 faces on that spinner. How many options do you have on that die, on that number cube? Neil, how many options do you have on the cube? 6, right? So you can only get 1 out of 6 options. If you have a spinner that has 10 options, how many options can you get? No, out of 10, the arrow can only land on 1. and a card is pulled from a deck of cards. How many cards are in a deck? 52. That's something you got to know for life. There are 52 cards in a deck. 52 face cards. This is something to know. If you ever go to Las Vegas and, I don't know, vacation there and go to one of the casinos, gotta know. I've been before. It's fun. It's hot.
Do you know how to count cards?
No. Depends on what game you're playing. Okay. And then you have one card. So pretty much when you are working with probability, you're multiplying a fraction. You're multiplying fractions. You're multiplying fractions. When we multiply fractions, we multiply. Yeah, we go top, top, and bottom, bottom. 1 times 1 times 1 is not 3, but it's 1. 6 times 10 times 52 is 3,000. I'm going to just tell you. 3,120. That means that you have 3,120 different combinations. That's why when you go to Sonic, it says we have 85,000 different drink combinations, right? That means that they have small, medium, large. They have cherry, vanilla, blah, blah, whatever syrups they have, right? And all the Cokes. They just multiply all the sodas times all the syrups times all the sizes. That's all they do. Have you noticed? That's what they do. So, in this case, you can have 3,120 combinations. You're just multiplying across. Now, last night when they flipped that coin toss,
I saw that.
right? Was that interesting? So who won the coin toss? Right, and they chose 2. Did they keep? They did a kickoff return, yeah. So that if you can control a lot of it because they were the team that was coming.
Teams play, do they do that to figure out the ball?
Yeah, they did. Did you see that amazing in return? 108 yards? Like the longest in history? 109? That could be you one day. Okay. Now, on this one, where it says a coin is tossed, a coin. How many faces does a coin have? A coin has 2 faces. Yes, heads and the tails. A coin has 2 faces, a heads and a tails. So you can only get 1 out of 2. Times a die is rolled. 1 out of 6. Think the number on the bottom is the possible solutions, the number of possible answers. The on top is what could happen. So when you multiply across here and across here, you can get, there are 12 different options. Heads 1, heads 2, so you can sit up, heads 3, heads 4, heads 5, tails 1, tails 2, tails 3, and so on. There are 12 options to pick from. The more options you have, the more choices you have, right? That's why when you play the lottery, it's like 175 million chance to win. Because for every number, there are 6 numbers, I believe, and you have up to number 50, right? So you have 50 times 49 times 48 times 47 times 46 times 45, right? Because once the number gets drawn, that's the chances. Your chances get really big to win. But again, that's a whole different story. Here, skip this one. All right, let's go down to the marbles here. The marbles question, because these are the ones that usually are asked. In a bag, there are 2 blue marbles, 4 white marbles, and 3 red. When a question like that is posed, these are easy. First, we have to figure out how many there are, right? So here, we need to add up the blue and the white and the red. Total marbles, 2 plus 4 plus, you have 9 total, right? 9 is your total space. 9 is the total number of options you have. Keep that in mind. The probability of 1 blue and 1 red, not replace, meaning you reach in, you take it out, you leave it out. Then there are numbers that change here. First thing you got to figure out, blue marble. How many options do you have for the first blue marble? No. Think about the total. There are 9 total, okay? But you haven't reached in yet. What are the chances that you could get a blue marble? 2. Because there's only 2 in the bag. You only have 2 chances to take out a blue. But it says not replaced. You're not putting it back here, people. So the number on the bottom now down to 8. Because now if you're wondering, well, there are 2 marbles. You're only taking out 1. It could be red, it could be white, it could be blue. Because you're not putting it back, this number will change. You only have 8 marbles left. How many reds could there be? 3. 3 red. Now, if you're wondering, well, you took one out. How do you know if it's red or blue? You don't know. This is a theory. This is based on theory. This is what could happen. Now, did it happen? No, we don't know. We haven't done it yet. So what are your chances of taking out blue and then a red? When you multiply across, Zakiya, 2 times 6, 72. But we got to reduce our fractions. Divided by 6. Now, 1 over 12. You have a 1 over 12 chance of winning. If you're guessing this, 1 over 12 is like 1 divided by 12 is, it's only 8% chance. That's really low. I would not bet on that. 1%, 8% chances. That means that you lose. That means you lose 92% of the time. No, not YOLO. YOLO got no money. Okay. Okay. So this right here, I would not be betting.
But what if I do?
Well, then you will win a lot. Have you ever look at the little spinner thing, the roulette thing table? It's a really interesting game.
Yeah.
It's like it's just chance. There's 36. There's black and white. No, there's red and black. I'm sorry, red and black, and there are 36 numbers, right? You can bet on odds, evens, even numbers, odd numbers, all red, all black. You can bet the top half of the top 18, the bottom 18, right? So, but if you bet on a specific number, you win like 8 times that money. But if you bet on like red or black, you only win 2 times, red or black. But you have a 1 out of 36 chance of winning. 1 over 36, you know what that percent is? 2.7% chance of winning. So you will lose almost 98% of the time. That's why the house always wins. Interesting? No? All right, let's go. Right. On the second one there. On the second one, just here, scoot back 1 seat. Now, on the second one, where it says probability of not red and not blue. Not red and not blue. Not red and not blue. Okay. Well, what colors are there that are not red?
White.
Okay, there's still, new problem. Out of 9, there's white and there is not red. Blue. How many whites and how many blues are there? Marbles. There are 4 white and 2 blue, so there's 6. Not red times. Now we have a new problem. Now, not blue. How many reds? And how many white? So you have 7. This one you put back, replace. That means the number in the bottom still is the same. Any questions on how I got the 6 over 9 and 7 over 9? Okay. Not red. What colors are not red in that bag? White and blue. So I add up the number of whites and the number of blue marbles. That's how I got 6. New problem. Not blue. Add the white and the red. The 9 stay the same because I'm putting it back. Okay. So then I multiply across. 42 over 81. I can actually divide that by 3, which is 14 over 27. Let's think about this one. Are your chances here better? Yeah, because guess what? It's almost, I think it's 47%.
49.
Is it 49 or 47? I don't remember. Actually, it's 52. Oops. 52%. Would you bet on that one?
No.
If you're a betting person, I would actually bet on that because you have a better chance of winning than losing. But you have a better chance of winning than losing.
What's that bottom number?
81. 9 times 9. 9 times 9. I would bet in this one because the odds of winning is much better than this. If you know your fractions, I'm telling you, you win every time. What? There's no green.
I'll bet on the no.
Uh-huh. Probability green is 0. 0. There is no green. Can't have anything. Can't have anything that's not there. 0. Green. 0. Okay, let's go to the back page. Zakia, sit down, please. Okay. No, we're not going to do all these, but I'm going to talk about some of these. On the top part where it says outcome, an outcome. What's another word for an outcome in science? A what? A product or a result? Okay, I'll buy that. It's a result or a product from an experiment. The result, the outcome. Think probability. Think event. When an event happens, it's like a party. I'm having an event in my house. There's an event at the store. There's an event at the restaurant. But in probability, an event is one specific outcome. One outcome. Or a result. It's the next one. From an experiment. All right. Here we go. I do want to go down to phone numbers here. Oh, actually, no. Sorry. Tree diagram, really quick. A tree diagram. I need the names of 3 stores you shop at. Walmart. Okay. Let's do Walmart. What else? No, I need clothing stores. Hollister. Forever XXI. Okay. Now, what are the 3 most common sizes at these stores? And shirt sizes.
Small, medium, large.
Right. Small, medium, large. Small, medium, large. Small, medium, large. Yes. Those shirts are about 3 sizes too big or too small. All right. So if you go to Walmart, you either have an option of getting a small shirt, medium, or large. Hollister, same thing. Forever 21. Right. So you have 3 options at the 3 stores. So what possible outcomes could there be? Okay. So the result could be you can either have a Walmart shirt that's small, Walmart that's medium, a Walmart that's large. You can either have a Hollister shirt that's small, medium, or large. Or you can have a Forever 21 shirt that's way too thin, by the way. Small, medium, and large.
Zoe Gilbert to report to the county.
How many options do you have total? 9. You have 9 options. 3 plus 3 plus 3. You have 9 options. Or, if you had seen this earlier, you can do 3 times 3. Same thing. That's how they figure out phone numbers, people. Let's figure out how many phone numbers there could be. Back when I was a little kid, we only had one area code, 214. Actually, you know what? I remember, this is a true story, that we didn't have to type in 214-972. We just typed in the number. Pretty old. And then it changed when I was a junior in high school. We had to use 214. And then it changed again when I was a senior, I think. 972 was a new number. And then 469 came out in 2000, I believe. 2000, 2001.
Not 2000, I mean.
I don't know. So let's figure out how many 972 numbers are there. 972. There are a lot. Let's figure out. Let's figure out 972 numbers. If you have a 972 number, let's figure out how many numbers there could possibly be. How many options do you have for the first x? How many numbers exist? Think. Technically, could 0 be a number? You have 10 options. 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 10 options. What other options could it be? 10, 10, 10, 10. Sorry. I got it. So somebody could have a number 0, 0, 0, 0, 0, 0, 0. Don't try it. I don't know what it is. Or they could have 999, 9999. It's that lawyer guy.
So somebody has a number.
Who? Some lawyer dude. I've seen his commercial. So how many 972 numbers exist? Okay, how many zeros do we have? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1. There could be 10 million phone numbers. But because we have 3 area codes in Dallas, 10 million times 3, 30 million phone numbers just in one area. That's how big Dallas is, people. 30 million phone numbers could exist. And we only have 1.8 million people that live here.
What about the whole world?
That's a lot. They have different phone numbers. Different places in the world have like 18 digits. It's
My
crazy.
cousin, not my cousin, my cousin has 936.
936? Where's that?
Logan.
Oh, I know. I actually knew that.
Well, who has number like
I have friends from San Angelo.
Angelina?
San Angelo. Wait, Lufkin's out. Yeah, what's...
B.
Oh, that way?
No, it's not. I'm not Mexican.
Okay, stop. Please don't fight. It's some girl, right? Or we get a new phone number. I got a new phone number once, and it was some person's old number that they owed a lot of money. And they kept calling. I goes, I'm not that person. Yes. All right, let's continue. Let's calm down. All right, quiz answer questions. Now, you take quizzes every week that have, let's say we have 5 problems and there are 4 answers. Okay? There are 5 questions on your quiz. And let's say there's A, B, C, and D. Okay? Times 4 options. A, B, C, and D. How many possible quizzes could I possibly make without repeating a quiz key? Meaning, somebody will have A, all the way to D, 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 D. Well, C. How many, for question number 1, how many options could I have?
20.
I could have 4, right? It could be all A, B, C, or D. How about number 2? Still 4, because it could be A and A. Question number 3. Still 4 options. 4. And then last question, no bonus. Now, if I were to make a quiz that did not repeat, that everyone got a different answer, how many options, how many quizzes could I make? 4 times 4. 4 times 4 here is 16 times 4. 16 times 16, you should know this. Now, 16 squared. Thank you, 256. Did you know that? Did you just know that? Times 4. 1,020. Now, close. There could be 1,024 different quizzes. I can make a quiz. A, B, A, C, A, D. I can make 1,000 quizzes, and everyone will have a different answer. That's why in the STAR test, there are 50 questions. There are 50 questions, and they're all different. Right, they're all different order. That's why they're different keys. Out. No tests are alike. So don't copy your friends. Okay. Questions, comments, concerns? Yes. Thank you for that's a great question. Tahira asked, why can't you do 5 times 4? Well, because 5 times 4 would just give you one option. We need option for this one, and this one, and this one, and this one, and this one. You have 5 questions. You have 4 different options. Let's say if you had 1 option for each one, then yes, you could do that. But you have 5 separate questions with 4 different options. You know, that's a great question. Answer yourself, please. Now, let's switch over to theoretical. No, independent and dependent. Here, we're going to do this, and we'll be done. The bell's going to ring. Okay, I hope this is making sense. No. Okay. Independent. Independent. We're almost done here, people. Independent events. Really quickly, it is 2 or more events. 1 event does not affect the other event. 1 does not affect the other. When you're independent, there's no one controlling you. Okay. Here, what about dependent? It does affect. Okay, hold on. Keep that in mind here. Let me pass this out to you. At the time, we're going to go ahead and we'll continue on the notes tomorrow with this. 4, 5, 2, 3, 4, 5, 6. Don't throw those notes away. We'll continue tomorrow on with this. Here we go. All right. Yep, you have 8 problems on here. You're multiplying it out. Number 1, Susan's creating a game that uses a spinner. The spinner has an equal chance. And there's a cube. One of 6 colors. Red, purple, green, blue, yellow, and orange. The fair cube has 6 faces. What is the chance of her getting a red? How many options are there? Colors. How many are there red? Only 1 is red. How about getting a 5 or a 6? How many options do you have for 5 or a 6 on the cube? Only 2 times, 2 options. When you multiply them going across, 2 over 36, which is reduced, 1 over 1/18, letter C. We'll continue on the notes tomorrow. When we come back, you have 7 problems to do. Hold on. You're going to be multiplying